I are both made of matter. I don't mean we matter like we're important, even though of course we are. I mean we actually are matter. Matter, as you know, is anything that has weight and takes up space, and we did a whole video about it. But what is matter made of? It's made of particles. So you, as a big thing of matter, are made of particles. The device you're watching this on is made of particles. Your dog is made of particles. You get the idea. Particles are so tiny though, you can't see them. Just picture them as super small balls packed together to form an object.
I'm the atom, the basic building block of all matter. I'm in everything from bicycles to ladders, to cars to chairs, to a puppy dog's fur, to the boots of a cowboy,
down to the spurs.
And I'm really, really, really super duper, really super duper, really super small.
Wow!
To really understand me, we gotta start with the fact that I'm made up of three main parts. They're called
Protons, neutrons, and electrons.
one more time, they're called
Protons, neutrons, and electrons.
the three parts of an atom.
So protons are made out of 3 quarks. That's the first lie you're told. Protons are not that simple. At any given time, the proton will have 2 up quarks with charge plus 2/3 and a down quark with charge minus 1/3, which of course all add up to +1 because that's the charge of the proton. These 3 quarks are known as valence quarks, and they're definitely there. But the proton could have an additional up quark anti-up quark pair. An anti-quark is the antiparticle of a quark. And it could have other types of quarks, pairs of strange quarks and anti-strange quarks, charm quarks and anti-charm quarks. In fact, the proton likely has tons of quark-antiquark pairs. But there's more. The quarks are held together by the strong force, which is carried by particles called gluons. So inside the proton, there are zillions of gluons and quarks.
Hi there, and welcome to Particle Physics Brick by Brick. In this series of videos, we're trying to explain as much about particle physics as we can through the medium of Lego. Now of course, I'm in no way going to convince you that a Lego brick is exactly like a particle. I mean, it can't be. It's made up of trillions upon trillions of particles. It's a macroscopic object, which means it's large enough for us to see with the naked eye. That said, we can use certain properties of Lego bricks to try and help us understand a little bit more about those underlying particles. And of course, what particle physicists love to do is they like to take matter and they like to break it apart and destroy it. Now, that's not because they hate the world around them, it's because by breaking apart the entire universe into its most basic building blocks, you can figure out the fundamental bricks from which everything is made. And this is the goal of particle physics. Now, a good thing about Lego bricks is, just like these fundamental particles, Lego bricks are essentially pretty much indestructible. As you can see, only 3 Lego bricks were harmed during the making of this video. Lego, I'm so sorry. But of course, the other goal of particle physics is to figure out how all of these building blocks piece themselves together to form the matter around us. Because at the end of the day, figuring out what set of building blocks you're supposed to use is only half of the battle. You then need the construction rules, and the construction rules tell you how to piece them together to create the final object you want. And this is one of the major goals of particle physics as well. So we get the building blocks, and we also now need to figure out what are the construction rules. This is a nucleus of a carbon-14 atom. This isotope of carbon is very special. It's responsible for carbon dating, but if we break it apart into its constituent particles, we see that the carbon-14 is made from 6 protons and 8 neutrons. Now, those of you already familiar with nuclear notation will already know this, because the two numbers that are written next to the element symbol of carbon give us a shorthand notation which tells us how many protons and neutrons there are. I think the real thing is it is a two-way stream. Some people view it as, okay, yeah, I'm going to a school and I'm teaching people about science. It's not like that. You learn something from the experience, whether it be improving your public speaking or, to be honest, looking at your research from a different perspective, because you can deliver what you think is the perfect logical process of any point of research that you want to explain. But as soon as that's reflected back at you by an audience, no matter what age, you start to see it from different angles, and that is what really changes and maybe makes you think about your research in different ways. So it's a two-way process, and it's fun. It really is fun. As I say, you get to do things you wouldn't otherwise do, go places you wouldn't otherwise go, and meet people and work with people that you certainly wouldn't otherwise work with.
Protons, neutrons, electrons, atoms. Protons,
All matter is
neutrons,
made up of me, made up of me. I'm tiny and you
atoms,
cannot see me, cannot see me.
protons,
Discovered in
neutrons,
1803, 1803. I'm an atom and I
atoms.
make up all things, make up all things.
It takes over 100 billion atoms to make up the head of a pin.
I'm the atom, the basic building block of all matter. I'm in everything from bicycles to ladders, to cars to chairs, to a puppy dog's fur, to the boots of a cowboy,
down to the spurs.
and I'm really really super duper, really super duper, really super small. Wow. To really understand me, we gotta start with the fact that I'm made up of three main parts. They're called
Protons, neutrons, and electrons.
one more time, they're called
Protons, neutrons, and electrons.
the three parts of an atom. So let's talk about protons first. They have a positive charge, like an energy burst. The second part is the neutron.
Yeah, we know.
It has a neutral charge, aka charge of 0. Now both parts that we just discussed hang out in a place called the nucleus.
Yeah,
Protons and neutrons, they both team up to make the center of the atom.
the nucleus.
But now we can't forget the third part. It's the smallest particle with a negative charge called ELECTRON.
Electron.
And it spins and spins around the nucleus of the atom, just like an orbit. And let me tell you one more thing before I forget.
Electrons are moving super quick.
They balance out the energy to make the atom legit. If an atom has more protons than electrons, it has a positive charge. If it has more electrons than protons, it has a negative charge. And these are called ions. Protons,
Have a positive charge.
neutrons,
Have a neutral charge.
electrons,
Have a negative charge. 3 parts of an atom, that's what they are.
protons,
All matter is
neutrons,
made up of me, made up of me. I'm tiny and you
atoms,
cannot see me, cannot see me.
protons,
Discovering
neutrons,
1803, 1803. I'm an atom, and I
atoms.
make up all things, make up all things.